Hi, I'm David. I'm the peer mentor for the watershed processing lecture, and I've been getting a bunch of questions about this project. And just so I think it may be easier if I just talk about this and run through a whole thing. I think it's just a better form of communication. So feel free, if this doesn't make sense, to go to Dr. Lobb's office hours on Monday or my office hours on Monday. I believe his is at noon. Mine should be, I believe, either at 2 or 3. I can double check. I'll put that in a post underneath this video. And I also put my email in there. So if you have any more specific questions, you can just email me directly. That's not a problem at all. I think a lot of people are trying to write out an Excel formula for this, in that because some of the things are bounded and therefore they can only go to certain limits or they can't go certain points, you might be getting the little things wrong and getting false inputs and outputs because of that. So I decided to make a little scenario here. It's different than your homework, okay? So it's not like your homework in that it's not an 8 inches is maximum storage, is a 10 inches maximum storage. I find that it's just easier to use here. It'll make my life a lot easier and make your life easier trying to understand it. So that's what I'm going with here. We're going to start with 5 inches already inside the storage right here. We're going to go to our first month. We're going to get 2 inches of rain in the form, precipitation, and we're going to get 3 inches of potential evapotranspiration. When we subtract those from each other, we get -1, and we're going to get a change of storage as -1. I think everyone's understanding that part pretty well. We'll go from 5 to 4, right? And there is no surplus, right? The storage actually went down. It did not overfill at all. There's no surplus. So nothing of that left the storage to go enter into the rest of the system, right? And that's why we have the 1 inch of groundwater coming out as 1 inch of discharge. So 1 inch is coming in from the groundwater, 1 is leaving out as discharge. So there's no room for any water to come out as groundwater, okay? And that's where groundwater is 0. Kind of to help illustrate that maybe a little easier, and drew out some stuff. And so hopefully my horrible drawing will help you out with all this. So with our first one, we know we had 2 inches, right? 2 inches of precipitation and 3 inches right there. Right? So our delta in here is -1. We're going to go from 5 to 4, right? So the water level is coming down. Nothing's spilling out over here, right? This is just changing. That is just a changing volume right there, right? So nothing's spilling out. We have 1 inch of groundwater coming out, and we have 1 inch of discharge coming out, right? So nothing is coming out as groundwater. There's no recharge happening there, right? I rearranged the equation over here. I don't know if my little head's in the way for y'all there. So I'm gonna move my head over here in case. I don't know if y'all see my head in the same place. I rearranged the equation. It's just some basic algebra. If you want to look at the top right there, you can see how I rearranged it. But I made so the groundwater output was the primary, was over on the other side of the equation. So we have 2 minus 3 plus 1. And if you're wondering why I said +1 and not -1, right? There's a negative change, but I put a +1 there. And let me show you this, because I think this might also be one of the reasons why people are it should be on El Internet. 1 second. Yeah, we're gonna go there, boom, and then we're gonna switch over here. Hopefully y'all see this. It says the change in storage is subtracted when the storage level increases, and because the water input will be needed to fill, and the storage, delta S changes when we lose something like that, we are going to add that, right? We're going to add it when the level decreases, right? And that's how we're going to do our equation. And it'll make sense when we finish our drawing, I promise. So we finished up, so we already finished the drawing, but then we add our groundwater, right? Groundwater is 1, and our discharge is 1. So we're minusing that, right? That's 0, and that right there is 3 minus 3 is 0. So our groundwater is 0. Hope that makes sense. Let's just first all that. So we can do this in a second. All right. So we're going to go back over to our Excel spreadsheet, hopefully. All right. Our next month, right? I think you'll also understand this from, say we have 6 inches of precipitation and 3 inches of storage, right? Or 3 inches of evapotranspiration. We're going to get a +3 change between, or difference between them, and we're going to get a +3 change, right? It's going to turn this to 7. Once again, we're not at a surplus with our storage. Nothing falls out. We get 1 inch in from groundwater. 1 inch comes out as discharge, so there's nothing to go as groundwater, right? This next one right here is the one that's a little trickier, okay? So we have a difference of a +5 between the precipitation, 6 inches precipitation, only 1 inch of potential evapotranspiration, right? We don't have 5 in change storage though. The max is 10, right? We're already at 7. We have 3. There's 3 change, right? That brings us to 10 right here. So there's 2 inches of water now, right? That has come from the sky, but is not staying in storage, right? That is flowing out and meeting up with all the rest of the systems over there. 1 more inch of groundwater is coming up, right? So now we have 3 inches. 2 inches of it is leaving right here as discharge. You still have that 1 inch, and that 1 inch is what's coming in as recharge or the groundwater output right there, okay? And I'm going to show you all that with my little silly drawing, because I hope that actually helps. So say instead of 2, and that, and all of that, we have 6, right? There's 6 inches of rain, tons of rain coming in right here. We already have 7. We have a little bit of rain coming out, right? That's a +5 right here, but there's only 3 coming in here to make this a fill this 10. 2 is spilling out. We get 1 of them right here coming in to give us 3. 2 of those 3 are coming out of discharge according to our chart. They already measured discharge for us, so we know that's where it's going. That leaves us 1 inch come out as our groundwater, okay? If we go here and do that again in here, we have 6 minus 1. It's going to be -3, because once again, it's an increase in that, so it's negative, just like that page on your water module. It's page 3 of the water module that talks about that. I recommend, if you're having a problem with that, read that. You know, plus our 1 groundwater output minus our 2 discharge right here, right? So we can just do this the old-fashioned way: -4, -6, right? -6 minus -6. So that +1, we have 1 come over here. There's 1 inch popping out that way. Okay. Ooh. Oh, hopefully, okay, stop that. All right, we're gonna come back over here. Hope and try not to make the video too long. So another important thing that we're gonna keep going, just got a couple more of these just to show you the rest of the stuff that might be a little confusing, okay? Say in an unprecedented situation, completely hypothetical, we have 11 inches of evapotranspiration and 0 inches of precipitation, right? We have a -11 on our precipitation minus evapotranspiration, but we only have a -10 here in storage tanks, because only -10 can leave. Only 10 inches are in there in the first place. You can only take 10 inches out, right? So we have 0 there. Once again, nothing's flowing out of the system, right? Nothing, there's nothing in the system, right? So nothing can flow out of the system to go into our outputs, right? So the 1 inch that comes in from groundwater is leaving as discharge. That is 0. That's 0. If you do the math on this, we'll actually give you a negative number right there, but you can't have negative water leaving through a system, right? You can't have negative water leaving, right? You can have negative water change, but not actually going in one of the directions, okay? And finally, we have over here, right here, say that there was, 5 inches of evapotranspiration, but once again, no precipitation, right? because there's no water in storage, there's no change because it's still 0, right? And we still have 0 here because we still have the same thing there. I hope that helps you out. I don't know, maybe I confused you more, hopefully not. But if it did help you out, good. If not, Dr. Lobb has his office hours on Monday. I got my office hours on Monday. I believe this assignment is due by the end of the day Monday. I'll double check that. And also feel free to email me, okay?